All right, now the next memory we're going to understand is called as procedural memory. Okay, now you can just go to this URL, okay, daviso.com, and you can read on procedural memory. Okay, now what is procedural memory here? Procedural memory is an AI agent's store of how to do things. Okay, whether it is skills, workflows, tool use, patterns, okay, and step-by-step routines. Okay, now what does procedural memory actually do? As it says, procedural memory is the learned skills, workflows, tool routines, etc. Your procedural memory directly impacts the system instructions of your agent. Okay, it basically suggests, or suggests your agentic AI or your AI agents as to how should it act. Okay, and how should it act is already or always defined in in the when I say it's basically in the system instructions, and that is what we're going to look at here. Okay, let us look at procedural memory store.py. Okay, here, but first and foremost, let me just fetch the Google Cloud Console. Okay, and yeah, just give me a minute. Yeah, let me just fetch the Google Cloud Console once, and I'll just show you like what do we need to exactly create. Okay, so let it open up. Okay, I will go to the instance, and in the instance I'll just go to Cloud SQL Studio. Okay, first let me just connect to my Cloud SQL Studio. Let it authenticate. I think here we were writing our queries, right? Now when you're going to write those queries, you also need to run one piece of code. Okay, you will be getting all these pieces of code in your VS Code. You will find all of them in your in your code repository only. Yeah, but what we're going to do is, because we are going to work with procedural memory, we're going to create one more table called as procedures, and you can see these are all the columns inside the procedure table. Okay, whether it is procedure ID, agent name, rule text, rule type, source, created and updated. Okay, now if you see here, we have created this table called as procedures, and in procedures these are the 7 columns that will be populated. Okay, so just make sure that you run this table, just how we created the table for episodic memory, which is episodes. Here we're also going to store the procedures. Okay, so please try to understand that is that is what we're going to deal with right now, which is the procedural memory. Okay, so again, procedural memory. Okay, here, yeah. Now the thing is, this file is going to give our agentic pipeline the ability to learn how to reason better over time based on the feedback from the human reviewers. Now if you can recall, we already have human in the loop, right? Now once you give human in the loop, which is the feedback, basis the feedback, okay, we want our agents to learn new things and kind of upgrade itself every single time, right? And that is what is going to happen here. So what is procedural memory? You can think of this as a junior doctor who started working. On day 1, they follow a simple basic checklist when diagnosing patients, and over the time senior doctors are going to correct them. For example, when a patient has both symptom A and symptom B together, always check for condition X first, then condition Y, so on and so forth. Similarly, our procedural store or procedural memory is also going to make our agents really sophisticated. Each agent starts with a set of default reasoning rules. When a human reviewer rejects a signal, which is basically it rejects what your agentic AI is or AI agent is giving in the output and explains why, then that rejection reason gets written into agent's rulebook, which means whatever human review will be given, that human review is going to update your procedural memory. Okay, so here there's a simple difference between what is episodic versus what is procedural. Okay, now if I'm talking about episodic memory, it is like what happened in the past sessions. But what is procedural memory? It talks about how to reason. Okay, the rules themselves. For example, when a trial was terminated early, missing results are expected and not the violation. This is like a rule book or the guidelines for the behavior. Okay, here I think we are not going to perform any embedding or so. We'll see. Yeah. All right. Now, what is the learning loop? The agent is going to generate the signal, which is an output. The human reviewer is going to look at it. Let's say a human rejects it with a reason that this trial was terminated early due to COVID. Missing results for terminated trials are expected. This particular reason, okay, is will get written into the agent's procedural table as a new rule. And what is that rule? Check if the trial was terminated before flagging the missing results. Terminated trials are exempt. Okay. Now the next time the agent runs, it loads the procedures first and it applies the new rule and correctly skips the terminated trials, which is fantastic. Okay, so this is how it is going to keep on self-evolving. Okay, we're not going to run this file directly and we're going to access the procedural table. Now these are the standard files that libraries we're always going to import. Okay, now before using this file, just run this particular, I've given this already here. We're just supposed to run this table. Okay, and what does each column means? Here procedure ID means the unique ID for every rule. Now every rule gets created for the agent behavior. So that rule or the procedure ID, it will have its own unique ID. Agent name, rule text, which means the actual reasoning rule in plain English. Rule type, which is either default or learned. So there are two types of rules. Either it is default that you're going to build in, or it is going to learn from the human in the loop. Okay. Then source. Okay, I mean when it takes the rule type into consideration, is the source from HITL rejection, which is a human, or is it default, which is initial right from the start. Okay, there are certain default rules, which means every agents start with these. Now these are built-in reasoning rules that every agent loads at the start of every session. You can see here we're defining some default rules for each and every agent. Okay. Now think of think of these rules as agents training manual. Okay, and they encode the base knowledge to what to look for. Okay, and when the human rejects a signal and explains why, a new rule is added to the database. Okay, so let us look at the default rules dictionary. Okay, each key is the name of the agent. You can see here each key is the name of the agent. Okay, and each value is the list of rule strings for that particular agent. Okay, so these are nothing but just some rules that we're defining. Okay, for example, missing results agent, it has certain system rules. Similarly, broken promises agent, it has some rules. Track record agent, it has certain rules. Okay, then similarly side effect agent, it has certain rules. Timeline agent has certain rules. Okay, all of the agents have certain rules or certain system procedures to follow. Okay, then we're going to define a class called as procedural store, which stores and retrieves the agent's reasoning rules, which are procedures. Now each agent has its own set of procedures, the rules that guide how it reasons about the clinical data. We have already discussed there are two types of rules. There is either default rule or learned rule. Default is nothing but the built-in rules. These are all the built-in rules. Or it is going to have learned rules, which are what the rules that are added when a human reviewer corrects the agent. Right? All right, this is how we're going to use it. Okay, just a simple idea. Okay, we're going to create a constructor. Okay, which basically runs when you create the procedural store. Okay, you can see the connection. Now this is we have already done. You can first and foremost it starts with a connection pool, which is none. Okay, it is lazy connection, right? Once the connection is created, it is going to suggest that procedural store is initialized. Then it is going to just check if the pool connection, or rather it creates the database pool collection and it checks if the database connection exists or not. And that is called at the start of every public method. Okay. If the pool, I mean, if the database connection already exists, it's not going to return anything. Okay. When it creates the pool, these are all the things that it takes into consideration: the host name, port name, DB name, username, password, all of that, and it creates a connection pool. And now you can just say procedural store pool has been created. We're going to create one more core method called as initialize defaults. And what does it do? It inserts the defaults rule into the procedures table. The procedures table that we have created, this function is going to insert those default rules in there. When are we going to call it? We're going to call it once when the mosaic or our entire pipeline starts up for the very first time. And after that, the rules are already in the database, and this method safely skips any that already exists. Okay. Why not hard code rules into the agent? Because we want the rules to be stored in the database and we want them to be persistent across the runs. We want it to be updatable, we want it to be visible, and we want it to be auditable, which means we can change it over the time. In case if the rules were hard coded in the agent, learned rules would disappear every time, and that is something that we don't want, right? Now, once we are, when we are, kind of inserting the default rules into the procedural table, first and foremost, to make sure that the database connection is open. Okay. Once the database connection is open, you check out one connection from the pool. You just check if any a connection is open or not, and whichever connection is open, you start kind of working with it. Yeah. So now you just loop for agent name comma rules in default rules dot items. Now this is the default rules dictionary, right? And in default rules dictionary, what is the items? Item is your key value pair. Okay. So it is going to iterate and it is going to take the key value pair from this dictionary. Okay, and then it is going to just loop over all the rules. Okay, so rules is what the list of rule strings for an agent, and from those rules it is going to extract the rule text. Okay, which is just what? One row equals to one rule. So agent with 4 rules will have 4 rows. Okay. Then we're just going to execute a connection where into procedures table, we are going to typically populate these 4 tables: agent name, rule text, rule type, and source. Here as of now, we are just giving the placeholders. On conflict, do nothing. Which means if the exact combination already exists in the database, skip the insert silently. Agent name is at placeholder 1, rule text is at place number 2, third and fourth are just default. Okay. Now, third placeholder rule type is default. This means that this is a built-in rule, and here fourth, which is source default, means it came from one of the default rules dictionary and not from the HITL. We're just going to log it, which means the default procedures have been initialized. Then we're going to create one more core method called as get procedures. What does get procedure do? Okay, it works first and foremost, it takes the agent name. Okay, which means for which agents rules do we need to load? For example, missing results agent. Okay, so each agent only loads its own rules. What does it give in the output? A list of strings. Okay, so this function that we see, get procedures, what is it doing? It is going to return all the reasoning rules for that specific agent, and this is called at the very start of every agentic session before the agent does any analysis. The agent reads these rules and incorporates them into the system prompt. You can see here, that is how it runs. The agent reads these rules and incorporates them into the system prompt so that GPT-4o can reason accordingly. And when we say that it returns a list, you can say it returns a list of string. What does it return? It returns your list of default rules and learned rules. This is how it returns. Okay, list of, so for example, flag missing results only if completed in 12 plus month, do not flag whatever terminated trials and co. You can see it gives you that. Okay, it is checking if the pool is there, if the connection is open or not. Okay, and then it is going to fetch the data. So what is fetch going to do? It is going to return all the matching rows and not just one, basis this SQL query. Okay, so here order by, we're going to put it in ascending, which means returns the rules in any order they were created. Okay, which means we want the newest one. We want the oldest one first. Okay, now we're just going to create a list comprehension here, wherein what we're going to do is for every rule we're going to extract that rule text, whatever rules it is, and we're going to store this in a variable called as rules, and finally we're just going to say that the procedures have been loaded. Okay, update from feedback, super important function which is self-explanatory. It is going to update from the human in the loop feedback. So it is going to take the agent name and then the rejection reason. Rejection reason is what human in the loop will give at an input level. Okay, for example, the reason the human reviewer gave for rejecting the signal. For example, this trial was terminated early due to COVID. Terminated trials are exempt from result posting. Whatever, it gives a string in the output. String means it returns the procedure ID, a UUID string. What does this function do, which is update from feedback? This adds a new learned reasoning rule from human rejection. Whatever rejection reason is given at the human in the loop level, basis that it is going to update your procedural memory, and this is basically learning loop in action. So when a human reviewer rejects an agent's signal, they explain why it was wrong. That explanation is passed to this method, and this method saved it as a rule in the procedures table. Okay, so it takes two things into consideration: agent name and agentic reason. Okay, you can see here we are again going to do the same thing. We are using fetch val. Fetch val just returns a single value and not a list of rows. Again, we're going to insert some data into the procedures table. You can see here agent name, rejection reason, all of that. Okay, here at placeholder 3, we're going to put learned. Learned is the rule type that we're going to set up here by default. Okay, which means that it has learned from the human feedback and also the HITL rejection. So when human rejected something, what was the reason given by the human, and we're finally going to log it. Okay, and what do we get into the output? We get the procedure ID, which is the UUID. Okay, all right. Then finally the utility method, which is to get all the procedures from API. Okay, this returns all the procedures for an agent with full metadata. Okay, we have created the get procedures function, which just returns the rule text. This method is going to return the full procedure record with the rule type, source and timestamp. So basically it is going to return everything. Okay, yeah, you can see it is going to check the connection, it is going to work with the connection, and basis that it is going to fetch this data. Okay, and finally what does it return? It returns these things. So your procedure is finally going to return so many things. It is going to give you procedure ID, agent name, rule text, rule type, source, which means either it's default or from human in the loop, and when was it created. Okay, this is what it is going to give you in JSON. And finally we write a connection, or we write a code that closes the entire connection. Okay guys, so that was about your procedural memory. And your procedural memory bases the input given by human in the loop. It is going to update the rules, which are of two types: learned or default. Learned, which means basis the human in the loop, it is going to update its system instructions. It is going to update its human behavior. That was about procedural memory. Now let's go to the next part, which is semantic memory and the last memory type. Okay, all right, thank you.